Okay guys, so today we're doing 4-6, congruence and right triangles. The very first thing that we need to know about is the hypotenuse-leg theorem. The important thing to realize about the hypotenuse-leg theorem is that it only works if you have two right triangles. So always make sure to double check that you have right triangles. For the hypotenuse-leg theorem, we need to know what a hypotenuse is and what a leg is. The hypotenuse is always the longest side that is across from the 90-degree angle. So I went ahead and marked those. I would suggest you mark those on your paper. Then we need two legs, so I've just picked another side. Either of the sides would work, but I went ahead and just went with the bottom. Now, the hypotenuse-leg theorem says that if the hypotenuse and a leg of one right triangle are congruent to the hypotenuse and a leg of another right triangle, then the triangles are congruent. This is just a known fact. If you think about Pythagorean theorem, it makes sense. A squared plus b squared equals c squared. If I know a squared and c squared, and those are the same, then b squared also has to be the same. We're not going to write out a formal proof on that. Just believe me. If you want, we can write one later. Okay, very first thing, we want to determine congruence. So, first thing I want to look at, do I have right triangles? So I'm taking a look, and I'm seeing that, yes, I do. Now I'm checking my hypotenuse and my leg. So my hypotenuse is 10. The other one is 10. One thing to notice when you are trying to decide which side is your hypotenuse, it is always the longest side of your triangle. So 10 and 10, they're the same. Now I'm looking right below that. I have 6 and 6. Those are the same. So yes, it is. The next one, here we go. We have these two triangles. So right now I'm looking, do I have two right triangles? I'm not sure. I see a right angle right there, but I don't see one on the other side. But I'm looking, aren't these two angles right here? Aren't they vertical? So that means that they have to be equal. So if the one on the right's 90, then that means the one on the left also has to be 90. Now, I'm double checking my hypotenuse. It's the one directly across from the 90-degree angle. That has two dashes. This one also has two dashes. I'm picking a leg, doesn't matter which. This one has one dash. This one also has one dash. So that tells me that I have a hypotenuse and a leg that are congruent. So yes, they are congruent to each other. Here we go. Very next one. Okay, the next one. Ooh, okay. We're looking at the next one. I kind of spoiled it for you. I went ahead and said no. Let's discuss why. Very first thing, I'm looking and I do not see any triangles, or not triangles, any squares right there. So that tells me that I can't be 100% sure that those are right triangles. So because of that, I cannot use the hypotenuse-leg theorem. It only works for right triangles. Very next one. Okay, so we're taking a look here. I said yes. Let's just double check to see why I said yes. So do I have two right angles? Yes, I do. Now I'm looking and saying, okay, I have a leg that's congruent and then another leg that is congruent. But I don't know about the hypotenuse. So I'm looking at the one on the left. The hypotenuse is the leg that's directly, or the side that's directly across from 90 degrees. So I'm going directly across. That's this piece right here, isn't it? So now I'm looking at the other one. I want to go to the side that is directly across from my 90 degrees. That's the same piece, right? So those have to be equal to each other. So yes, based off of the hypotenuse-leg theorem, those are congruent. Next part, here we go. A proof! This is the best day ever. Okay, proof number one. Very first thing that we want to write down is our given, right? Yeah, of course, you know that. So, I'm looking, I know that I have some right angles because of the fact that they're perpendicular. So RTU and RTS are both 90-degree angles. It also shows it in my picture, so I'm just going to say that's true. I don't feel the need to have to write that out because of the fact that I wrote perpendicular. So, based off of that, if I have a right angle and a triangle, that tells me that RTU and RTS are both right triangles because of the definition of right triangles. Right triangles have to have a 90-degree angle, right? Okay. After that, I'm looking at my picture. We already know that RU is congruent to RS. That's our hypotenuse, so we're good with that. Now I need a leg that's congruent. So I'm looking, and I'm noticing that on both of my triangles, they use RT. RT is one of my legs. So can I say that RT is congruent to RT? Yes, I can. The reason is the reflexive property. Okay, so now We have a hypotenuse that is congruent. We have a leg that is congruent. We have two right triangles. That tells me that I can use the hypotenuse leg theorem to say that my triangles are fully congruent. Or we just use the shorthand for it, the HL theorem. So go ahead and take a second. Make sure you have that all written down. You can pause the video if you need to. I'm going to go ahead and move on. The next one, here we go. So we are now looking at, where are we at? Okay, so we have a picture right here. I'm looking at my picture. I'm seeing, it says use the information given in the diagram. So I'm taking a look. I'm seeing that I have two right angles. So I went ahead and said angle A is 90 degrees, angle C is 90 degrees. I know that AB is congruent to CD because of those little dashes. So I went ahead and said, oh, that's given. Now I'm looking at what else do I see? If I have right angles, that tells me I have some right triangles. So triangle ABD and BCD are both right triangles because of, again, the definition of right triangles. So now I'm looking and I'm seeing I have a leg legs that are congruent, but I need a hypotenuse. So I'm looking for my hypotenuse. I think it's this piece right here. It's the longest piece. It's directly across from my right angles. So I went ahead and said BD is congruent to BD because both triangles use BD. The reason for that is the reflexive property. Then I'm looking, I've said my hypotenuse is congruent. I said a leg's congruent. I have right triangles. Those are all the pieces I need to be able to say that I have hypotenuse leg theorem for triangle congruence, or HL theorem. Okay. We just went through two proofs so fast, so make sure you take a second, have that all written down, all understood. You can pause the video again. Okay, let's go ahead and move on to something else real quick. I want to look at the second page. Okay, for what values of x or x and y are the triangles congruent by HL? So I'm looking and I'm saying, okay, I know my legs are congruent and I want my hypotenuses to be congruent. Well, the first hypotenuse is 17, so that means the other one has to be 17. So that one took no math at all. We're just saying x equals 17. Okay, number 2. So, again, I have right triangles. I know the hypotenuses are congruent, 4.25. I need the legs to be congruent. So they told me one triangle's leg is 3. That means x has to be 3 for the other one for them to be congruent. So again, no math, pretty easy. Very next one, here we go. Okay, this one took a little bit of math. So let's see what we did. We need our hypotenuses and our legs to be congruent. So I looked, and my hypotenuses say 13. So I have 13 and 4x plus 1. I want those to be congruent, right? So I set them equal to each other. So 4x plus 1 equals 13. I subtracted the 1 over, so I had 4x equals 12, and then I divided by 4, which got me x equals 3. So I'm done with that. Now, I need my legs to be congruent. So that's one leg, that's my other leg. I'm going to set those equal to each other, but they have an x and a y. But I already know what x is, so I'm just going to plug in x. So I have 2 times 3 plus y equals 8 times 3 minus 2y. So I multiplied, I got 6 plus y equals 24 minus 2y. Then I went ahead and subtracted the 6 over, and I added the 2y. So y plus 2y is 3y. 24 minus 6 is 18. Then I divided by 3, so 18 divided by 3 is 6. So that gave me x equals 3, y equals 6. Go ahead and take a second and try out the next one. Go ahead and pause the video, wait, try it, and then come back to us. Okay, next problem. Here we go. Let's just double check. So I'm looking, I want the hypotenuses to be congruent. So that tells me that this is congruent to this. So I set them equal to each other. 2x plus 1 equals x plus 3. I subtracted an x over. I subtracted a 1 over. That just got me x equals 2. Now I need the legs to be congruent. So this is equal to this. So x plus y. I don't want to have two variables, so I just plugged in 2 for x. So 2 plus y equals 3 times 2 minus 3y. So 2 plus y equals 6 minus 3y. Then I added the 3y's over, and I subtracted the 2, so 4y equals 4. That just got me y equaled 1. Everybody should have gotten the same thing. If not, go back, double check your math, make sure you didn't make a simple mistake somewhere. Make sure that you set your hypotenuses equal to each other and the legs equal to each other. You can't switch and swap them together. It has to be hypotenuse equals hypotenuse, leg equals leg. One last part. I know that you guys have been waiting for this all day. Another proof. This one's great. This one's one of my favorites. It's pretty easy. So I'm looking. Very first thing, we have BE bisects AD at C, and AB is perpendicular to BC, DE is perpendicular to EC, and AB is equal to DE. So I'm looking at my picture. They went ahead and marked that my two triangles have right angles, so I can see that pretty easily. Then I'm looking and I'm saying, okay, they said that, what was it? AB is congruent to DE. Yeah, that's already marked. So BE bisects AD at C. Bisects means it's cut in half, right? So that tells me that AC equals CD. So I went ahead and marked that on my picture, but I also wrote that as my next statement. So I said AC is congruent to CD. My reason is definition of bisector. Bisector says it is cut in half. So that means they have to be congruent to each other. Now, I went back and looked. I saw, hey, I have some right angles. What does that tell me about my two triangles? They're right. So ABC and DEC are right triangles. My reason is, again, definition of right triangles. Very last part, just double checking our picture. We have our hypotenuses are congruent. We went ahead and said that our legs are congruent. We have right triangles. So we just checked off all three criteria needed for hypotenuse legs. So I can say that ABC is congruent to DEC because of the hypotenuse leg theorem. That's the end for these notes. Go ahead and look them over. Try out the homework. It's the same thing. Once you finish that up, make sure you work on your delta math and get your discussion question done for this week.